Good morning. So I wanted to just do a quick recap of everything that we've done in 4.1 so far. This is not going to be by any means the same length as a full lesson, but I thought I'd kind of just go through what we learned. What we really talked about the first couple of days is we talked about how this point right here is the vertex. We call it the central angle because it's on the origin. In order to create what's called a angle in standard position, you're going to create first your vertex on the origin. From there, you're going to go onto the x-axis towards the first and second quadrant and create a straight line. And then from there, you create your angle. You can create any angle you want. I created an angle of 225, but you could create an angle of 45 degrees. Either way, this last ray that you're drawing is called the terminal side, while the first ray you drew on the x-axis is called the initial side. So I'm going to be testing on standard position. It's pretty easy. Just make sure your origin and your vertex are on the same place. Make sure your initial side is on the x-axis in the first quadrant, and you should be good to go. All right, so let's keep on going. Okay, these are just some definitions. You can kind of look at them on your own, but we're going to go through these as we work. So the next thing we talked about is what's called a positive versus a negative coterminal angle. So a coterminal angle is literally just imagine that you have the same angle, but you get to it a different way. So for example, we might have the angle 45 degrees, which, maybe that's my favorite angle. Who knows? We have the angle of 45 degrees. In order to get 45 degrees, we're always going counterclockwise. Counterclockwise means that your angle is positive, while clockwise means that your angle is negative. So the question is, how could I get to negative 45 degrees using a different method, I suppose? So instead of getting to negative 45 degrees by going down, I could actually get to negative 45 degrees by going up and around 315 degrees. And so what that is called is a coterminal angle. So 315 degrees is coterminal to negative 45 because they create the same angle. You just get there a different way. A positive coterminal angle is just going to be whatever ends up being a positive angle that is the same. And a negative coterminal angle is going to be whatever is a negative angle that ends up being the same. A great way to find a negative versus positive coterminal angle is just take your angle and add 360 degrees. It creates the same angle. Or for negative, take your angle and subtract 360. So that's a really rough overview of positive and negative coterminal angles. Next thing we talked about this in class, and radian is kind of the newest concept, the concept I really want you to understand after this lesson. So imagine that if I wanted to go from inches to feet. If I want to go from inches to feet, I can totally do that. It's really just a matter of finding a unit converter. The same thing is true of radians and degrees. Radians are a way to measure an angle. So in the past, you've measured angles using degrees. But today, we want to talk about a new way to measure angles, which is by using what's called a radian. So let me go ahead and define what a radian is and how we use it to measure degrees. So imagine we have a circle here, and it has radius r. If I were to take that radius r, and let's say we took radius r like it was on like a string, and we kind of stretched it all the way around the circle as far as we could go. So I'm going to take the radius r, and I'm going to stretch it around the circle as far as it will go. We call this S. S is what's called an arc length. And so the amount of r that goes around S actually creates an angle here. If I create another straight line to connect S with my vertex, and the angle that's created in between is going to be called a radian. We're going to denote it as theta, but basically this is just a new way to measure an angle. So in order to figure out what a radian is, I'm kind of just going to roughly do this. We're going to see how many of these radii are going to fit around the circle. So if I add another radii here, so another length of r here, we're at 2. And then I add another one, we're at 3. And we did this as an investigation in class. So it looks like there's 1, 2, 3 radiuses that go around half the circle, which means if we go around the full circle, we're going to get 6. In fact, we actually proved this later. It's a little bit more than 6. It's actually 6.28. And right here is 3.14, which you should recognize as pi. So what we can see here is that if I wanted to count how many radius go around an entire circle, doesn't matter what circle, it's actually always going to be 2 pi. So the amount of radiuses, so the red line, if I stretched it across, to go around the whole circle takes about 2 pi, or it takes about 6.28 radians, or it takes 6.28 radii to go around the whole circle. And that's how we're going to try to measure angles from now on. We're going to come back to this, but theta, which is your radians, is equal to arc length over r, is a formula we're going to use fairly often, but we'll come back to it. All right, so what we wanted to do next is we kind of wanted to just define things in terms of radians and then define things in terms of degrees. So we went around in class and defined that this is 0, this is 90, this is 180, this is 270, and if I go all the way around the circle, I'm 360 degrees. So the question is, how many radians is each degree each degree measure? We talked again that in order to go halfway around the circle, it took us about 3 radii. In fact, using our proof, which we're going to skip today, it's actually going to take exactly pi, or 3.14 radiuses, and we'll call it radians, to go around the circle. So we can say that 180 degrees equals pi radians. They're the same. It's like me saying that 12 inches equals 1 foot. If to go around halfway around the circle is pi radians, to go halfway around the circle should be pi over 2 radians. And also to go all the way around the circle, if half is pi, to go all the way around the circle is pi radians. So that's basically what we did there. And this is just a brief intro to this. What we talked about next is we just practiced. So this was just a practice sketching angles in standard form. If you sketch an acute angle in standard form, you can see here it's always going to be in the first quadrant. If you sketch an obtuse angle in standard form, it's going to be in the second. So that's kind of just what we did there. All right. Once again, we practiced finding positive and negative coterminal angles. The only addition that we did here is that instead of finding them in degree mode, we found them in radian mode. In fact, the process is going to work the exact same way. To find a positive coterminal angle, instead of adding 360 degrees, we're going to add the equivalent, which is 2 pi radians. So before we saw that 360 degrees on that circle equals pi radians. 2 pi radians. And so in order to find a positive coterminal angle, if I start off in radians, which is pi over 4 here, little hint, pi over 4 is 45 degrees when we learn how to convert. All you need to do is take your initial angle and add 2 pi. To find the negative, you're going to take your initial angle and subtract. So that's just a little review there using the new units. Last thing, we talked about complementary angles. Complementary add to 90 and supplementary add to 180. In radian mode, complementary are going to add to pi over 2 and supplementary are going to add to pi. So the generic formula for finding complements versus supplements is to take your initial angle. Oops, can I go back? Uh-oh. Is to take your initial angle, which is right here. In this case, it was pi over 3.
I'm going to interrupt you.
Oh, yeah. Oh, you're fine. Okay, sorry about that. So the next thing that we're going to do, we left off. Okay. The formula for supplemental is going to be the same. So normally to find a supplemental angle, you're going to take 180 and subtract it from whatever angle you have. But because we're dealing in radians, we're starting off in radians, we're just going to do the equivalent, which is pi. So in order to find a supplemental angle, you're just going to take pi and subtract it from the angle that you're given. Okay, let's go ahead and keep moving. We're going to skip that. Okay, so this is kind of like the next big thing. This is kind of what we did yesterday. The next big thing here is we talked about how do I convert from radians to degrees and degrees to radians anytime I want. And the best way to think about this, honestly, you can memorize if you want, is to think, how do I go from inches to feet? In order to go from inches to feet, I need a converter. I know that there are 12 inches in 1 foot. So say if I had 5 feet and I wanted to go into inches. Well, back in middle school or maybe early high school days, we learned unit conversion. Unit conversion involves me saying, okay, I have feet in the numerator, so I want feet in the denominator so they cancel. There's 1 foot in 12 inches. Feet cancel with feet, and we get 60 inches is equal to 5 feet, which happens to be how tall I am, which is just incidental there. So the same thing's going to happen with radians and degrees. In order to go from radians to degrees, we need to know 2 things that are equivalent. I know that pi radians is equal to 180 degrees. Because of that, I can use a unit converter, specifically the first one here. If I want to convert from degrees to radians, all I need to do is multiply by pi radians over 180 degrees. For example, if I have 135 degrees, in order to go into radians, I can say 135 degrees times, okay, I want degrees to cancel. So notice how 180 degrees are on the bottom, radians are on top. So we're going to say 135 times pi radians over 180. And if you use your calculator here, 135 divided by 180 is 3/4. And we'll show that later. And so what we're going to end up getting is 3 pi over 4 radians. And this is the way I want you guys to express your answers, not as a decimal, but exact if you can. The same process is just going to work in reverse when it comes to going from radians to degrees. And we have an example of this here. So say we have 7 pi over 4. If I want to go from 7 pi over 4 radians to degrees, all I need to do is make sure that my radians in my unit converter are in the denominator so that they can cancel. And then notice how this is convenient. The pi's also cancel too. Pi in the numerator, pi in the denominator. And so what we get is 315 degrees. Okay, I know that was a lot for today, but that is everything we've done in the past 2 or 3 days. If you have any questions, feel free to email me or message me or set up some sort of meeting, and I would love to answer your questions. I hope you have an awesome day and work on your web assignment.